Hello everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. In this lecture video series, Statistical Data Representation, in this video we are going to see frequency distribution. So in that we can split this frequency distribution into two types. One is cumulative frequency distribution and the another one is relative frequency distribution. So in this presentation we will introduce the concept of frequency, cumulative frequency and relative frequency distribution and explain the importance in data analysis. So here let us see the introduction to frequency distribution. First let us see the definition and purpose of the frequency distribution. A frequency distribution is a summary of how often different values occur within a data set. Its primary purpose is to organize and simplify raw data into more understandable format. So here let us see the importance of frequency distribution in data analysis. So first one is it is used to summarize large data sets concisely. Next, it reveals the underlying distribution of the data. Next, it helps in identifying pattern, trends and outliers. Next is it forms the foundation of creative visual representations like histograms and bar charts. Next is basic frequency distribution. So data is grouped into classes and the number of observations in each classes is encountered. This count is called the frequency. For example, when we see in an example exam scores. So let us see let us consider the ranges. So from mark 50 to 59, 2 students scored and 5 students scored marks in the range 60 to 69. Then 8 students scored marks in the range 70 to 79. Then 6 students scored marks from the range 80 to 89. Then 3 students scored 90 to 100. So that can be represented in the histogram. Next is cumulative frequency distribution. So next is definition. Let us see the definition of cumulative frequency distribution. Cumulative frequency is the running total of frequencies. It is the sum of the frequency for a given class and frequencies of all preceding classes. Why it is useful? So it helps us see how many data points fall below a certain range. So this is useful for finding medians and percentiles. For example, you can quickly answer how many students scored less than 80. So next is let us see calculating of cumulative frequency. So as we seen in the last example, 2 students scored between 50 to 59, 5 students from 60 to 69, 8 students from 70 to 79 and 6 from 80 to 89, then 3 from 90 to 100. So cumulative frequency can be found by taking first value, next adding the first value with the second value, so we will get 2, and in the range 50 to 69 on adding 2 and 5 we will get 7. Next for the next range adding that 7 with the next value 8, so we can get 50 to 79. There are 15 students scored in that range. Next 6 plus 15 which is 21, so therefore in the range 80 to 50 to 89 21 students scored, and 21 plus the last value is 3, therefore 24. So total number of the final frequency will be equal to the total number of students in the class. So next is cumulative frequency chart. This is also known as ogive. So let's see what is ogive. An ogive or a cumulative frequency polygon is a line graph that plots the cumulative frequency against the upper class boundary. That is, it's an S-shaped curve that is useful for estimating the number of observations that lie below a particular value. So we can plot the previous thing in the ogive. The next one is relative frequency distribution. So first let us see the definition. So relative frequency represents the proportion or percentage of the total observations that fall into a specific class. It is calculated by dividing the class frequency by the total number of observations. Next is let us see the importance. So it's standardized frequency, making it easy to compare distributions from different sizes data sets. Expressing data in percentages is often more intuitive for interpretation. the next one is how to calculate the frequency distribution, relative frequency distribution. So let us consider the same example. So for the first one, let us totally there are 24 values, that is from cumulative frequency there are totally 24 students. So on dividing the range, so first 50 to 59 we have seen that it is 2 students, so 2 by 24 will be the percentage, so which is 8.3. So the next one is 5 by 24, which is 20.8 percentage. Next is 8 by 24, which is 33 percentage. Next 6 by 24, which is 25.0 percentage. Next is 3 by 24, which is 12.5 percentage. This is how we have to calculate the relative frequency distribution. So next is relative frequency chart. This can be plotted in a pie chart. So for interpretation, pie chart can be used. So a pie chart is a perfect visual for relative frequency. The entire circle represents 100% of the data, and the size of each slice is proportional to the relative frequency of its class, making it easy to see the contribution of each part of the whole. So combinedly we can for a data set we can find both cumulative frequency as well as the relative frequency. Applications and importance, real world uses. So business, analyzing sales figures per region. In healthcare, tracing the age distribution of patients. Next in marketing, surveying customer satisfaction levels. Next in science, measuring experimental outcomes. So let us see the informed decision making. Understanding data distribution is crucial for identifying key insights and making strategy decisions. So this method transforms raw number into a clear story about the data. So let us sum up the concept. So frequency distribution, which is used to organize data by counts in specific classes. Next is cumulative frequency distribution, so which provides a running total of frequency showing totals below a certain points. So this will be visualized using a ogives. Next is relative frequency distribution. This shows the proportion or percentage of the data in each class. So this shall be visualized using a pie charts. Together these three distributions offer a comprehensive toolkit for summarizing and interpreting data. Thank you.